Hello friends, welcome to my channel. My name is Fikrat and this video is part of video series dedicated to learning Microsoft Fabric. In the past few videos, we have started discussion around Lakehouse in Fabric. So we learned core technologies that are at the base of Lakehouse. We discussed Medallion architecture, which is recommended architecture when you build your Lakehouse in the cloud. And we talked about three layers, three zones that are part of Medallion architecture. That's bronze, silver, and gold. We also learned bringing data to a Lakehouse. So basically, we explored few ingestion tools that are available within the Fabric. Today we are starting discussion around transformations technique in Lakehouse. And in the first video, we are covering bronze zone. So you may remember from previous discussions that bronze zone is the first zone which receives data from source systems, and its structure for the most part is identical to your source system structure. Having said that, when ingesting the bronze zone, common practice is to apply certain minimal transformations, like enforcing your schema, adding certain columns or removing certain columns, cleansing certain dirty data, or adding some metadata. Excited to take you to that journey. Follow me to learn more. Here's a quick preview of what I'm going to cover today. We'll start by exploring PySpark APIs for ingesting CSV files. And then we'll learn certain transformations, PySpark transformations that can be useful for so-called schema enforcement. These are transformations that allow you eliminate certain columns and rename certain column names. Then we'll take a look at filtering methods that can help you to cleanse dirty data. And then we'll explore some deduplication techniques. And then we'll take a look at some useful functions that allow you to add metadata information to your data. Finally, we'll take a look at techniques to parse semi-structured data. So in this case, I'm going to explore JSON files. A quick reminder, if you are new to the channel, please take a moment and subscribe so that you could be always up to date with my latest videos. Let's get started. All right, I am in Microsoft Fabric's homepage. I created Lakehouse named Bronze for the purpose of this demo. Let me navigate to that Lakehouse. And the first step is going to be to upload the files. So I have prepared a couple of CSV files, and I'm going to upload them in unmanaged section of Lakehouse, which is the folders located under files. So I created a couple of subfolders here, and I'm going to upload files to CSV subfolders. So I'm going to click three dots, select uploads, upload files, and navigate to my local folder where I have two files. I'll click open and upload. So these files are exported from AdventureWorks database that represent customer and sales information. And I'm going to share a link for them in the description of my video so that you could repeat the experiment. Okay, so the next step is to open the notebook for this demo. I'm gonna navigate to existing notebook command, and from here I will select lesson 305 data transformations bronze notebook, which I will share link for in the video description as well. So we'll click open, so you can download that notebook and import into workspace. Okay, so let me close this panels and make it a little bigger. So this is PySpark notebook, and it has certain typical transformations that you would see in bronze layer, bronze zone injection. So my first step starts by reading CSV file and creating data frame here. So I'm using read API, which we discussed in past videos, and I say the format of my files is going to be CSV, and I specify a relative path for this file. So let me run this. And let's take a look at the data. Scroll down. Few things to notice about data. First of all, column names are incorrect. So they have been inferred by read API. So I'll need to change these column names. And then we have more columns than I need for this demo, so I'll need to remove certain columns, unnecessary columns. Another observation is that I have some rows which are not really useful from my data frame perspective. So you can see that anything above row number 4, they're useless. So I'm gonna exclude these rows. And if I scroll down, we can see that there's certain rows with empty values in all columns. So we'll need to filter out them as well. So let me scroll down a little. And let's take a look at different columns. So we have numeric column here. And we have tax amount, also numeric column. However, we have certain rows where we have NAs, so string values, which will need to be eliminated as well. Okay, so let's take a look at the first transformation. So as a first step, I will be excluding all the unnecessary columns, as well as renaming columns to meaningful names. So for that purpose, I am going to use a few methods here. So first thing to notice that I am using this data frame and applying certain transformation in chain, and then result is also assigned to the same framework. So that we create we kind of refresh data frame by applying this technique. So the first transformation cells achieves two goals. First of all, it renames the columns to meaningful names, and then it will eliminate unnecessary columns. So let me start by describing this command where we have data frame. We are reading from data frame, applying certain transformations in chain, and then result is assigned to the same data frame. So in other words, we are refreshing this data frame. So my first transformation is using withColumnRenamed method, which you can see here. And it receives two arguments. The first argument is existing column name, old column name, and the second argument is new column name. So I use this method to rename 4 columns here. And then I use drop method and list columns that needs to be removed. So this is one way of eliminating unnecessary columns. And then I use select method, which achieves 2 goals. First of all, it specifically tells which columns needs to stay. So you can say that you can see that I have included a few column names here. But also I am demonstrating here another technique to rename the column. So first of all, I refer to the column by its old name. So I use call function, and then I use alias method to rename it. So this is what it does. And in order for this to work, I need to import PySpark functions. So call functions from PySpark SQL functions library. Okay, let me run this. And scroll down. So my data looks a little better now. I have eliminated unnecessary columns and I renamed to meaningful names. So as a next step, I am gonna eliminate data irregularities, so row values, so incorrect row values. There are multiple ways of achieving that in PySpark, and the filter and the where methods are some of the common methods. So here I am using filter method, and I say filter out any rows where order date is empty or sales order ID is empty. And here I am using where method, which basically has similar syntax. Okay, so let me run this. If I scroll down and take a look at the data, now my data looks much better. So all these empty rows are gone. So my next transformation is taking care of adding extra metadata information to the data. That's another typical transformation that you will see while ingesting into Lakehouse. And to achieve that, I am using withColumn. So withColumn is one of the best methods to create calculated columns. It receives 2 arguments. The first argument is the name of newly created column, whereas the second argument is expression. So you can include any Spark expression here. In this case, I am using built-in function input file name, which will bring source file's name. The next method is similar, so I'm using withColumn as well. However, in this case, I'm bringing here insertion date time, and I'm using current timestamp built-in function here. Okay, so let's run this. And if I scroll to the right, my metadata information have been added. And okay, so let's scroll down and take a look at the next transformation. So deduplication is another common transformation. You want to ensure that your incoming data is free of duplicate data. And to achieve that, I am using dropDuplicates method here. And this method requires subset argument, which will include list of primary keys from this data frame. So basically, if I look at my data frame, I know that sales order ID is the only primary key, and that's why I listed here. But if your data if your data has more than one column, that so basically, if your primary key is combined key, then you can list all these columns here. So let me run this as well. And finally, I will use write APIs to write in the delta table. So here I am specifying tables format, and I say added to the table's end. So I specify append mode, and finally I use a table name. I'm using save as table method to write into the table. So one thing to consider when you are writing in the bronze tables is your table write mode. So I think it makes sense to use append mode for the most tables, so that you can always keep adding new versions of rows and keep them in bronze table. That way you can take care of, you will have full history of your data in bronze, and then you can remove duplicates going when you go to silver zone. Having said that, for some tables, for some simple tables, it makes sense to use overwrite. So you don't need to worry about history in these tables, and you can use overwrite as a mode here if that's the case. I'm gonna use append mode and run the cell. Okay. And the next few cells basically repeat similar transformation in regard to customer file. So let me first read this file. One thing is different here is that I am specifying header option here because I know that column names are there. The column names are present in this file, and I also know that the column names are listed as a first row. So when you have such case, then you can basically tell header is true, and read APIs will infer column names. So as you can see, we have column names listed here, which makes transformations slightly easier. So you don't need to rename these columns. Okay, so let's scroll down and move to next transformations. Here I am demonstrating another example of chain transformations. So first I'm using select transformation to eliminate unnecessary columns. Then I apply filter to eliminate empty rows. And finally, I am using write APIs and basically specifying table name and write mode. All right, now that we have seen how to apply basic transformation techniques to structured data, let's explore parsing semi-structured data. So specifically, I'm going to look at parsing JSON files. I have JSON file here, which has play data. It contains cake recipes information. So as you can see, it has multiple levels. It's so nested JSON. And at the top we have certain field names, and some fields have further structure under them. And you may also notice that this is so-called multi-line JSON. So you can see multiple records starting and ending here. So just like array. So let me upload this file to my Lakehouse. So I'll just create subfolders on the landing and upload my file. Okay, so let's scroll down to the bottom of this notebook. So my first cell has been auto-generated from Lakehouse Explorer using the same technique I have demonstrated earlier. We are using read APIs to read from JSON file. Here, instead of CSV, I specified JSON as a format. And here we have option that says it's multi-line JSON. So if I run this cell, so you can see that this read APIs basically flattens first level of JSON. So the top level JSON fields have been assigned to columns. Some columns have simple data types, whereas others have structured information. So if I expand this batters field, I can see batter field under that, and you can have we have some array data information here. So let me scroll down. So this command allows you to see structure of data frame. So if I just run print schema, so we can see this nested structure of this JSON. So we have array. At the beginning we have struct. At the top we have struct data type, and under them we have batter field and we have array. So let's first try to parse some parts of this batters column. Now we can easily refer to any parts of this the first level struct type information data. So here we have batter, so we can refer to that using dot notation. So this is what my first command demonstrates. So you can see we have column, batters column, and we are just adding dot and column the field name. So that should produce content of batter field. If I scroll right, so this is my field. So as you can see now, batter column has become array type, and then now I can flatten this array type using explode method. I'm going to use explode method, and will provide this batter column as an argument. I should mention that this function alongside with call is part of PySpark SQL functions library. So whenever you use it, make sure that you include this line. So let me run this. And so new column name is batter array. And if I take a look at batter array, now we have individual records that's part of array. So now this has been flattened, and as you can see, we have more rows here. Let me demonstrate another technique which could be useful if your structured field has too many fields underneath. So in this case, we have only two, and we can easily extract all of them at once. So that's what my next cell does. So as you can see, we have here, I am using select method, and I provide my complex column name, so better array column, and I say, and I then provide dot and provide star. So that should extract all the fields under this column. Run this. And now these fields have been extracted. And once the unstructured data has been parsed, then similar techniques that we have seen at the beginning of this lesson can be applied to this data frame as well, and results can be written to Delta Lake tables. I'm not going to write into Delta Lake as it's not required for future for the further demo purposes. That concludes today's discussion. To summarize, we learned common techniques and Spark transformations that are relevant when we are talking about bronze layer. We also learned parsing different file types, including CSV and JSON. I hope you enjoyed. Thanks for watching, and I'll see you in future videos.